Good morning and welcome to another webinar by Micrographics. I'm your host today, Colin Royan. Today we'll be looking at Autodesk factory design utilities. We're going to be taking a closer look at 2D assets. This is another webinar in the series that I'm doing covering the factory design utilities. I've done a deep dive into factory assets from the 3D side with Inventor. I've done a general overview webinar as well. So please feel free after this video to go have a look at our YouTube channel and search there for factory design utilities. You'll find some videos there covering some other aspects of the factory utilities. But for today, we are looking at 2D assets and working with 2D assets inside of AutoCAD, doing our factory layouts in AutoCAD, and a couple of different options that we'll be looking at within AutoCAD. So on today's agenda, we'll start off just with a basic introduction. Then we'll look at using 2D assets within AutoCAD. Then we'll have a look at how do we actually create 2D assets. And then we'll have a look at what are known as chained assets and how do we use chained assets? How do we convert chained assets? We'll talk a little bit about what that means later on. And then seeing that we know then how to use them, or what they are, how we convert them, then we'll have a look at how do we actually create chained assets and publish a chained asset into the asset library inside of the factory design utilities. We'll then close off with a summary and questions and answers section or session. So just for our introduction, this webinar is based around assets, and when you have the product design and manufacturing collection, you get factory design utilities as part of that. And essentially, factory design utilities allows you to quickly and easily create facility layouts. It doesn't have to be a factory, it could be a warehouse, it could be a shopping center. It just has a vast library, existing library of common objects from within industry. Things like safety fencing, conveyor belts, robots, forklifts, pallets. There's a wide variety of common objects within the existing library, but it may not be fully complete depending on your industry. So there may be things in there that are more specific to your industry, especially if you have turnkey equipment. So as part of the asset library, we need to be able to create our own assets. So in this case, you might be needing to create something that's industry specific, that is specialized, and you may not be able to find it in the existing library. And these custom assets can be created as 2D assets, and more often than not, they are created as a 3D asset, and we can then assign custom behaviors to these assets. Now, typically, when we talk about custom assets, we'll find that we can create and publish assets from within AutoCAD as well as within Inventor. But the whole idea behind the factory design utilities is that we leverage the 3D environment within Inventor to be able to get a feeling for three-dimensional space. It's not just a floor plan. We have height that we have to take into account as well. We can see in the image on the right-hand side, we've got conveyor belts that might be running above head height. We've got to take into consideration the height of the spiral conveyors, the robots on their pedestals. There's that Z-axis that needs to be taken into account. So with this being said, we do find that there are a lot more options when publishing from within Inventor when it comes to publishing our assets. So what we'll see today is what is available within AutoCAD, and my previous factory design utilities webinar went through the process of publishing a 3D asset from Inventor. But as I said, today we're looking at the 2D. So in a nutshell, the factory design utilities, when it is installed as part of your, let's say, the collection, product design and manufacturing collection, it bolts on these asset libraries that are available, or that is available both in AutoCAD and in Inventor, and they are linked. So we'll see here basically the asset browser that is available in AutoCAD. It would look exactly the same in Inventor, but from the AutoCAD side, using the asset browser is very basic. It's basically just a drag and drop process to pull an asset out of the library, drop it down into the layout, and then from there in your layout, you can essentially link those assets together using their connectors. Once an asset is dropped and placed into the environment, into your layout, you can then assign asset properties, things like your size of the asset, its configuration. So for a conveyor belt here, if we're dragging and dropping in a corner conveyor, from a size perspective, we can set the belt width, the height, the let's say the radius of that corner, various aspects with regards to the conveyor itself. The wire merge conveyor there, we'd be able to set the angle of that merge, once again the width of the belt, the height, and so there's different properties that we can set up for those assets as they're dragged and dropped in. For assets like conveyor belts or fencing, where the connectors, or where they are connected to adjacent like assets, so we have corner conveyors connected to straight conveyors, connected to wires, those connected assets can update. So if we change the width on a single asset, then the connected assets will then also update their widths so that we do not have to go to each individual asset and change that property. So when using 2D assets with this drag and drop, we have flexibility in the placement of these assets. We can pull in a straight section, we can pull in an inclined belt, a spiral belt, and we can build up the system as required. However, this can sometimes be a little tedious if we have repetition, and what we're going to look at a little bit later on is the chained asset type. So that is something we'll get into a little bit later. If we have the same asset that repeats multiple times within a facility that are connected, so like a very long conveyor belt, we'll have a look at that, would be part of the chained asset types. But these assets here, dragging and dropping just individual assets, allows you the flexibility to pull in various different types or configurations and then set properties for each of those objects that you drag and drop. The nice thing about this is that once your asset has been pulled in and it is placed on the 2D layout, you are then able to use standard AutoCAD tools to manipulate that asset. So in this case here, in the three images, I've got a shelving unit there on the bottom left-hand side, the left-hand image. We've got the robot with a shelving unit on the left, and we've used the built-in array command from AutoCAD to array that shelving unit 4 times, and then the decision is made at a later stage potentially to move 2 of those shelves. So we see here that the top 2 shelving units have been moved and rotated to open up a gap between the shelving. That also reducing, let's say, the distance to the conveyor belt. So you're able to stick to the standard AutoCAD tool sets that you may already be used to with regards to arraying, copying, pasting, moving these blocks, these asset blocks around within your layout. So essentially you drag the asset in from the browser, it's inserted as a block, and you can work with that block with the standard process that you may already be used to when doing layouts in AutoCAD. So we'll do a demo on this. I'm going to jump into AutoCAD. You'll see that I've got this layout here already within AutoCAD. So there are a couple of individual blocks that have been placed. So having a look here, if I click on a single conveyor here, I'm just dragging out the factory properties. We can see what layer that is currently on. So it's currently on layer 0. And we have some model properties that we can adjust. So we have things like feet, gap, height, legs. So we have all the legs, no legs on that conveyor. And there's even length options, number of rungs. So we've got a whole lot of options on this specific asset that we can adjust. As I mentioned, the width, we may want to update the width. So I've got this, see this is here at 600, and we have a chain of these conveyors. And let's say we need to reduce this down to 500. We can update that property and hit the update icon to commit that change. And that width update will carry through the conveyors of the same type or that share the same connectors. I see here in my case that this one has not updated correctly, so I assume that I have an issue there with the connector between the two. So this is what happens when you go off script. Okay, so I would need to go in there and just double check what's going on with that, why that did not update. But we can also grab multiple conveyors as well of the same type. So let me grab just these two at the bottom, and we can also do a multiple change here on all of these conveyors. So I typed in 600 there for the width and enter, and it'll update both of those to that size. Now, if I do need an extra conveyor, we could easily grab this and use standard options. So we can go clipboard, we can do a copy with base point or just a standard copy and paste. I'm going to go ahead here, copy with base point. So I can grab a base point on the right hand side, and then I'm just going to use Control V to paste, and I can go connect. We'll drop that conveyor down to get a feel for the layout. Part of the layout is also being able to connect, or one of the tools that we have here is being able to connect these. So we'll have a look at the connect or connectors enabled option. If I click on connect, we'll see that certain objects will have available connectors for us to be able to choose. So the end of the conveyor belt here shows an available connector. I could connect this up to another free conveyor block that is standing out in the open. Just with regards to the shelf, we showed this in the presentation. I'm going to go ahead here to my favorite, and I'm going to just drag and drop that rack in. It then gets attached to the cursor. You can then use your placement tools to select where to place this down. Let's just say coordinate systems or snaps. I'm going to go ahead and just eyeball this in the corner here. And we can always choose orientation as well. I'm just going to go here, keep the orientation out to the right so that the rack is going up. And then once again, as I mentioned, standard AutoCAD tools, I'm going to use the array command. Select the component to array. I'll right click, and at the bottom here we've got some options. So I want to do a rectangular array on this one, and I'm going to use the inputs at the top. So I want one column, I want 4 rows, and the storage length here is 4064. So I'm going to set the between to that 4064 millimeters. and we then get that array of shelving units. And I'm going to set this off on the associativity so that it creates 4 individual blocks. Close the array. This allows, if we need to grab blocks and move them individually. You could always explode the array and achieve the same thing. And I'm just going to basically just do a very quick move here. And I'm going to grab this bottom right corner here and move it up to the top point and then rotate. So you'll see I'm not doing anything fancy here to get new components in or to move the components around. I can even just use the standard move command, and let's say move this down. Let's go about 4 meters and get that into a new position. So just using, once that asset has been dragged and dropped in, just using the standard AutoCAD commands to then position that block. And also when selecting the block, we are able to make changes to the block properties itself, model geometry, as well as properties for that, or view the properties for that block. Okay, so that's some basic use of the 2D assets and moving them around within the assembly. What we'll do is we'll jump back into the presentation and we'll have a look at, well, how do we create a 2D asset? And the 2D asset creation will start basically with your block creation. We need to create that 2D block that can house all the information, the attributes for the component that you want to place down. So you're going to have asset geometry. It can be simple or complex. On the right hand side here, I've got two blocks showing a simplified version and a more complex version of a packaging machine. And this can be drawn from scratch within AutoCAD, or it can come from the 3D model. Now in this case here, I had a 3D model of the packaging machine, and from there we exported or created a 2D drawing from that model, and then I simplified that down, removing a lot of the geometry from that. So you will pick which way you want to go. You may already have existing blocks for machinery that you have for components or assets that you have within your facility. And so you can take that existing library of blocks that may just be standard AutoCAD blocks and then use them and publish them into the Factory Design Utilities asset library. This one here, basically an export from Inventor. You would create the block within AutoCAD, and then if you need to, you can also put in attributes from or attributes into the block. So as an example, when I talk about attributes, I spoke in the previous slide and during the demo about factory properties. So that could be things like the description of the asset. It could be a revision or part number. There's an asset tag, a descriptor. These can all be included in the block as attributes. And there are also the ability to create custom attributes. So any attributes that you have within the block already can be converted to custom attributes so that custom properties can then populate those attributes. Once you have your block, you would then go into the asset builder. And part of the asset builder would be to set up your asset properties that we just spoke about on the previous page. So you would fill in your descriptions, your part numbers, all the information that's required to identify the asset itself. And part of the asset creation in AutoCAD, or from the AutoCAD side, is to link a 3D representation. Now you don't have to, but if you are wanting to go into Inventor with your layout, you then are required to, or you would want to have a 3D representation that is aligned with the block. Now, we'll see in the demo when we bring in the 3D representation, we do need to validate that 3D representation and get the position aligned correctly with the block. If you don't include a 3D representation, part of publishing would be the option to actually just extrude that block to a set height. So we get a spatial requirement or view of the object that we are creating. So if you do not have a 3D model, it can be created during the publishing and then modified in Inventor if needed. So during the asset builder process, as mentioned, you'll fill in the properties, you will set up the 3D model, you'll edit the block if needed, include more attributes, change the geometry, and then you'll go through the publish process. So just breaking this down, having a look here at the asset properties. I've just got a couple of screenshots just to have a look. Essentially, the asset properties we fill in here will be tracked in the factory properties palette in AutoCAD and also in Inventor. So when you select the block or the 3D model, these properties will show up. These properties can also be exported to Excel so that you can have a list of assets and properties. And these will also carry over to Inventor and populate the properties in Inventor. For those of you that are Inventor users, you will recognize these properties. They are basically your Inventor R properties that we are filling in here. And with that being said, this information will carry through to the Inventor bill of materials as well. So there we've got just a second tab there, the descriptor tab, showing the asset descriptor. I've called this custom machine, and then the extended description packaging machine for foil packets. There is also a layer tab. This is important from an AutoCAD perspective. If we choose to specify the layer for the asset, you would then give the layer name. So there we've chosen a layer called, or put in a layer called new machines. So when this asset is placed down, it'll go onto a green layer called new machines. And below that is a selector layer list that is empty. This is a list that can be pre-populated using a template file. You may have a template file that has existing layers. Could be layers for safety equipment, machine guarding, walkways, equipment, electrical equipment versus mechanical equipment. So you can separate your facility onto different layers. So when you publish a new asset, you can choose which layer that asset should go down on. So this is a packaging machine. It should go down onto a machinery layer. And within the factory options, you can specify a drawing. It will pull the list of layers from that drawing and populate that list. If you do not specify a layer for an asset, so if you uncheck the box at the top, the asset is placed on the active layer in the drawing. So if you're on layer 0, that asset just gets put on layer 0. And lastly, customizable. These are properties that, or custom properties that you can put in. So you can see I've put in here a pack rate of 100 units per minute, and that can be included in a custom attribute. Mentioned the attributes earlier in the block as well. So we can actually see the pack rate for this unit. This will carry across as well to Inventor's custom R properties. Then during the publishing process, you're also able to link a associated 3D model or you can extrude from the 2D block. So this is where I mentioned earlier, if you don't have that 3D model, you can choose to extrude from a 2D block, and you can set the extrusion height. So when the 2D asset goes to Inventor, it'll be extruded to the specified height to give you that volume requirement or space requirement of the object. If you had already loaded a 3D model in and validated the 3D model during the asset building process, you would then choose to associate the 3D model, browse, and then select that 3D model to ensure that you are showing the correct 3D model when publishing. And I mentioned part of linking that 3D model is actually validating it. So if the 3D model is not aligned with your block, you are able to move and reset landing surfaces and rotate that model so that it lines up. So we can see here, when I brought in my 3D model, it was rotated out of alignment and it needed to be rotated back. So we're going to jump into a demo here of that process. And what we have here on screen currently is, let me just go out of the asset builder, is that block. So if I click on the block, you will see that it is an existing block. I have already done a bit of asset building on this block. However, if you just had geometry converted to a block, that would be your starting point. And factory properties, if you clicked on it, the factory properties would be empty. I'm just going to use this existing asset here. We'll go into Asset Builder. And if you do click on Asset Builder, you will see if your block browser is open, it'll say, please double click a block in the list below to enter the building, the Asset Builder environment. If you don't see the block browser, when you click Asset Builder, it will open the block browser. So here we can see Packaging Machine. It has been published. I'm going to double click on that to go into the Asset Builder. And then we see the steps that I mentioned in the presentation. We have asset properties. We would go through and we would fill in the properties as required. So because I've already built or published this, we already have those properties filled in. 3D representation. I'm going to go ahead and just go through this here. So as we click 3D representation, we can choose how do we want to associate that. Do we extrude from the 2D block or do we associate the 3D model? I'll go ahead and browse and load in the 3D model. Let's take a little bit of time to import that 3D model. It shouldn't take too much though. Sorry, once we've linked it, we have to validate. That will then load it. My apologies. So there we can see the 3D model has been loaded and it is not positioned correctly. So here I'm going to hit rotate and I'm going to rotate around the Z axis and we should get it. Try and get it to snap. So there we go. Get it to snap there, and we now have that. Go to the top view here. We have that machine lined up. So I'm happy with that from a validation perspective, orientation perspective. You'll see the edit option, edit block will open the block editor, allows you to edit the block, and then publish asset. Clicking on the publish asset will bring the asset publisher up. Now the asset publisher, we can choose to publish asset according to the name. So there's packaging machine, and we can either go to a local or a cloud library. And so I've got a user assets library here. There's my previously published asset, packaging machine, and I'm just going to go ahead and republish to that same location. I may have changed some properties. There may have been some geometry changes, and so we want to just replace the old one in there. So I'll hit OK. You'll see it says replace blocks. Any existing blocks in the drawings will, active drawings, will also be replaced. I'll hit OK, and we're going to hit OK to replace that asset. And this will now go through the process of publishing out that asset. I'm going to let that run in the background. We'll come back to that. What I'd like to do while that publishes is just talk about asset chains. So up to now, we've been looking at individual assets, just pulling in a length of conveyor belt, dropping it down, setting up a length and setting up its properties, then pulling in another length of conveyor belt and linking it. Did the same with the racking, the shelving. Bring in a shelf, array it 4 or 5 times to get what is needed. Now, asset chains, now what that does is it can tend to be repetitive. Drag and drop, change properties, copy paste. You can spend a lot of time working that way to get, let's say, a long line of conveyor belts set up. And what assets chains do is it allows you to quite quickly and easily replace these. So if we look at asset chains, basically what we're looking at is a long line of assets. So conveyor belts being the most popular sort of example. You could have a long line of conveyor belts with a turn and then another long section, a long stretch of conveyors with multiple turns. And they're all essentially very similar or the same as far as the asset goes. And it can be time consuming to place down. So what asset chains allows us to do is it allows us to use a placeholder polyline. So you would draw a polyline inside of AutoCAD, or you may even have existing models where you have got, or layouts where you have got polylines drawn in to represent where your conveyor belt goes, where your fencing goes. And you've set a width of that polyline to show the width of the conveyor belt or asset that would run along that line. And so you can use those existing polylines and convert them into an asset chain. Or if you have an asset chain that you want to use, you can then draw that polyline from scratch. Now, the nice thing about this is that it will use the maximum length of object. So let's say the conveyor belt maximum length is 3 meters. It'll fill in that entire length of that polyline with 3 meter lengths of conveyor belt. And if there is a shortfall somewhere, let's say there's a small section that has to be put in that is 1 meter long, then it will reduce the length and put in a custom length as a filler. And it'll also populate corners so that we have corners placed in as well. So this automates the process of placing down assets. So as an example here, on the right-hand side, we've got a polyline coming off the conveyor belt, just representing maybe new conveyor belt that's going to be added to expand the production line. And the polyline has a width. Now, I've drawn this with a radius in the corner. You actually don't have to. You could leave the corner sharp, and the asset chain will replace that sharp corner with a corner asset with the default radius that is used. In this case here, I've drawn it so I can get a feel for what that space requirement is for the radius there. You might not get this with a sharp corner. So how do we use asset chains? How do we place them? How is it different to standard assets? The idea here is that it is still drag and drop, but there is one thing that we do need to consider. Most assets are going to be directional. So there's a connector 1 and a connector 2 on the corners. Connector 1 is the start of the corner. Connector 2 is typically the end of the corner. So when you place down a chain of assets, the corners are directional, normally working clockwise. So what you would do here, just bearing that in mind, is you would select the asset chain from the library, and then you would either manually draw in the polyline. Now, once again, I've got a corner there on the polyline, a radius. You don't have to. You can just have a sharp corner, and it will replace it with the corner type for the asset that you have chosen. Or you could select an existing polyline. One thing to note, in the asset browser, you can identify chained assets by the little assembly and chain link on the top left corner of the asset chain. So we can see there's guardrail chained. There's also the handrail chained. It would normally be in the name as well. So you would find that chained asset, drag it across into your layout, and you would then either draw your polyline or choose the polyline option to select a polyline. Now, when you draw the polyline or select an existing polyline, you'll see there's little to no detail on that polyline. So if I go back to these two previous slides, we've just got this polyline that is a solid white bar. And this slide here, the polyline doesn't even have any width, so we don't know how much space is being taken up. And that polyline may already have the assets assigned to it. So if we open this up in Inventor and synchronize it, we would see the three-dimensional asset populate along that line. Now what we can do in AutoCAD is we can convert that asset chain. So we can take that polyline and convert it. What it will do is it will fit in the blocks for the various assets. So here we have a conveyor belt with the before and after options showing us the polyline before conversion, and after we can see that it is 6 conveyor belt sections. So we can see more detail, we can get a full bill of materials, we know there's 6 sections and they are treated as individual assets. Then on the right-hand side, we can actually see some red assets there. These are those fillers. These are the non-custom sizes. So we have basically starting on the right-hand side, a full-length conveyor belt. We get to the filler at the bottom right. This is working clockwise, as I mentioned before. And then it places the standard corner, a standard conveyor, then a custom length once again. So you'll see working in that clockwise direction, the custom length is always added before the corner. But we now have those individual pieces to get a full bill of materials on how many conveyor segments we need. So we're going to go into a quick demo here on this. So let me go over to AutoCAD. I'll go over to this assembly layout, and on the factory tab here, oh sorry, not on the factory tab, just close the properties for now. Just in the main window, we've got this existing polyline. I'm going to go ahead and add to it. First thing I want to do is just quickly drop in that packaging machine. We want to pull a conveyor through to the packaging machine. The packaging machine had finished publishing, so it is now available in the asset browser. And we got some of those properties visible on that custom block. And now with the polyline, we can either use the polyline command, and essentially draw in a polyline. I'm going to just track from the center of the conveyor belt, and I'm going to go down and just draw in a basic polyline there. You could also use your standard line commands, fillet commands, and then join those together to create a polyline. What I'm going to do here is I'm going to use join to join these two polylines. So I'll grab those two polylines. So now it's joined that entire length. Let's say from a space perspective, I'm going to go polyline edit. I want to see how much space this takes up. I'm going to change the width here to 600 for all segments. and we can see where the conveyor belt runs. Note I have a mix of modeled in corners and sharp corners. The sharp corner will be replaced with a standard conveyor belt length or size. The drawn in corner would have the custom radius there. Now to have a look for a chained asset, I'm going to go system, conveyor, I'm going to keep this simple, belt conveyor, and we see there is the belt conveyor chain. I'm going to drag and drop that. And at the bottom here, it'll ask pick a start point or select a polyline. So pick a start point means I can draw in a conveyor belt length. So I could start from here and go up just a random length, and that draws in a length of conveyor belt for me. Alternatively, drag and drop and choose polyline. That will then allow me to pick an existing polyline, right click and convert that. So polylines have been converted to asset chains. I'm going to bring up the factory properties. You will notice when we select a asset chain, factory properties stays blank. It is still seen pretty much as just a polyline. If I go into properties and select, we will see that it is a polyline, and there is nothing too, let's say, special about this. But what we can do now, if we want to actually see how that is broken down into the different conveyor belt segments, we can choose convert asset chain and then select the asset chains we wish to convert and right click enter, and that will then convert those asset chains. We could also open in Inventor, so we could use the open in Inventor command to go across to Inventor, open, and then have it populate in Inventor as well. It's just AutoCAD. There we go. So there it shows our custom lengths and a custom corner, our standard lengths here, custom length, and we can see that conveyor belt has been populated. Now, out of interest sake, let's go open in Inventor and save the document first. And this will now open up in Inventor. We can actually see the polyline there in Inventor. And then it brings in the layout. Let me just go update assets. And we would then see that update here inside of Inventor. I just want to check something. Okay, so I'm running into a little bit of an issue here. For some reason, it hasn't populated this here in my Inventor. There we go. Let me just try to do the update. Okay. I'll have to troubleshoot. This should automatically update here, but for some reason I seem to have, it does not want to update, and this is the joys of doing these demos live. Okay, we are concentrating mostly on the 2D side today though, so I'm not going to worry too much right now about trying to troubleshoot what I broke so that it's not opening up there. I got a feeling I was messing around with layouts. We can create sub layouts. I had the conveyors on a sub layout and I deleted that, so I probably broke something there on my side. But that is asset chains. You can draw in polylines, use existing polylines. Sharp corners are replaced with curves, and we'll see now. I'm going to go through the actual creation process of the chained asset and what is required to achieve this. So jumping into the chained assets, what we do need for chained assets is we need to specify what is considered a straight portion of the asset. So what is the straight length? And What we need here when we generate these assets is we need to have parameters that will drive the length of the asset. We can also do width and height parameters. We need to publish with the landing surface as well as connectors, your start and your end points. So connector 1, connector 2. I'm not going to spend too much time here. You'll notice that this is actually in Inventor. And as mentioned right at the beginning, you are limited to what you can do from a 2D perspective before you have to go to Inventor and build your asset in Inventor. So for chained assets, you do need to build the asset in Inventor. Use the asset builder in Inventor to apply these connectors and landing surfaces. So we set up a straight segment. Then we need a turn segment. And we actually have 3 different types of turn segments we can create. Here we have the conveyor belt. We have, which is known as an arc turn. And the important thing here is the radius. We have that radius set. But you'll see we also have height, width, and angle. So the arc turn gives us a radius in the corner. We also have a straight turn option, which gives us a sharp corner. Here we have a length 1 and a length 2. This example of a wall has the 2 sides of the wall, length 1 and 2, and the connectors on either side, as well as a corner angle, height and width. And then the third type is what's called an extended arc turn. So we have that corner, a rounded corner, so it's an arc, but it's got extended straight ends. This one here is just representing essentially threaded pipe fittings. We've got the elbow with the 2 threads or the female ends on that pipe. And the important one here is that we have that extend 1 and extend 2 parameters. We'll go a little bit more into each one of these. The arc turn segment, parameters that are important here are the angle and radius. You can also set up your width and height parameters as well. Landing surface and connectors, start and end, are obviously important as well. On the straight turn segment, as I mentioned, there's the length 1 and length 2. So you have your 2 separate sides of the turn with their lengths. Then your height, width, and angle as well available as parameters. Then the turn segment, the 2 extension sides on the turn segment with the extension. So you've got extend 1 and extend 2. Those are the respectively the lengths at the start and the end of the turn. And then we have angle, radius, and width, which, because in this case it's round, it's also your height, but you could have width and height parameters depending on the type of object you're creating. Okay, so just a very quick look at this inside of Inventor. I'm just going to go into the asset builder for this turn segment. I'm not going to go for all of them, but what we'll see here is I've got the sweep of a cable tray, and we have here parameters that are key parameters that will be used, the radius and angle. In this case, the model, the height and the width are fixed, so we're not including those, just the radius and angle under the key parameters. But also we have the connector 1 and connector 2 connections on either side of that turn. So just a very quick look there at the 3D model. Asset builder here inside of Inventor, you would go through landing surface, define connectors, asset properties, including a 2D sketch, and then eventually you'll publish the asset. And this is the important thing. These straight segments and corner segments, you would pick what corner segment type you would have. So this is just the standard turn, and then a straight. And you would publish these into your library or into your assets as 2 standard components. So you would firstly publish your individual components, your straight segment and your turn segment, and then you would go through the creation of a chained asset. Now the creation of a chained asset here is done from within the factory tab. So if we go back to factory, we can do this from the AutoCAD side. So the chained asset we grab in AutoCAD, you'll see the create asset chain command. So if you want to create that asset chain, you first publish out the two segments, and then from there you would just go through the wizard step by step. So I've got the screenshots here from those various steps. The first step is to fill out your basic information. So here we've got the name for the asset chain. So I'll call this custom cable trays, the units, and then some asset chain properties. So properties specific to the asset chain itself. Author company keywords. Once you've filled in the first page, you then move on to the second page, and this is where you specify the straight segment. So under asset, you would select asset and browse your asset browser and choose what is the asset that is used for the straight segment. You would then set your start and end connector names. So I've just used connector 1 and connector 2. And then below that, you would choose your parameters that are important for this. So in my case here, the width and the height, I'm leaving them unmapped. They are, let's say, a standard off-the-shelf size, and there's no other size options, but the length can be customized. So the length is not unmapped. We're setting that to the key parameter of length in the model, and then a default and a minimum value. Once you're happy with that, you move on to step number 3, where you can choose what type of turn you are going to be using for this asset chain, arc straight or extended arc. You would then browse and select the asset, and depending on your option that you choose at the top, your parameter options at the bottom will change. And so there we are mapping the angle and the radius and setting the values as required. Then lastly, you publish out your asset chain. So you would choose your publish location. Here I've got a cloud library called test equipment that I published this to. So you would select either a local or a cloud library destination. And from there, your last step is a summary where you can then edit and change things if needed. Otherwise, you would hit OK, and that will then publish that asset out. So in this case, I'm not going to go through the demo of publishing that. The steps there are quite straightforward in that wizard. What I will do though is here inside of AutoCAD, I'll go ahead to that cloud library. I'm going to use a cloud library, test equipment. Here we can see the cable tray cover and the turn, as well as the cable tray chained asset. So if I double click on that and draw a polyline, so let's say I want to go from here up and I want to go left to lay some cable tray. We'll go ahead, place the polyline down, and I'm going to go ahead and convert this immediately, and it will then convert that asset. There we go. And so we can see, okay, my published model here had a couple of other details on it, but we can see the custom length, the standard corner, and then we've got more components added. So a nice, quick and easy way to fill in a long chain of assets that line up end to end and include corners quite quickly and easily. And that brings us to our summary. basically looking at 2D assets within AutoCAD. AutoCAD makes it quick and easy to place down assets, do a very quick facility layout, production line layout, using your basic AutoCAD skills like copy and paste an array. Once you've dragged those assets in and dropped them down into the layout, those AutoCAD skills can just come in handy to align everything up. From a 2D asset creation, it is possible from within AutoCAD. You can predefine attributes, but there is that limited functionality. One thing that you'll run into is connectors. You cannot define your connectors in the 2D side. So those connectors have to be defined in Inventor. Your landing surface defined in Inventor as well. So you'll find that you'll probably follow the process that I covered in one of my previous webinars, where you would publish from the 3D side and generate the 2D blocks. But if you are just stuck to the 2D side of things, you don't want to work too much with Inventor, it is still possible to publish assets from the 2D side, even if you need to use just a very little bit of Inventor. But we are able to publish 2D assets. And then lastly, asset chains. Very useful for assets that line up end to end, can turn corners, and are repeated multiple times in a layout. Conveyor belts, cable trays, cable covers, fencing, walls. All of those examples lend themselves well to being asset chains. They're easy to draw the path, quick to place down multiple assets. It reduces time and reduces the repetition. And I don't have it here, but the best of all is if you already have those paths drawn in, even if they're not polylines, you can quickly convert them to polylines and then assign the asset to that polyline. So you can use existing geometry quite quickly and easily. And that there brings me to the end of the presentation from my side. What I would like to do now is just open up to any Q&A, see if I get any questions coming through from anyone who is tuned in live. If you are not tuned in live, if you are watching the recording, feel free to place some comments or some questions. My details are also on screen. You can email me any questions you may have, and then I can get back to you with regards to those questions. Just going to give some time now for any questions, if there are any participants. I don't see any in the live chat or in my participants list, but I know that has been wrong in the past where it hasn't updated, so I'll give another second or two. Okay, there's nothing coming through, so we'll then close off the webinar. I'd like to thank you for your time. If you did watch portions of this live, or if you have watched the recording, then thank you for your time and your attention, and hope to hear from you if you have any questions or if you have any interest in the factory design utilities. Once again, my name is Carl van Rooyen, application engineer at Micrographics, an Autodesk Gold partner. Please, if you did enjoy this, go have a look at our YouTube channel. We've got plenty of other webinars and tips and tricks and short videos, longer videos available there, not only for factory design utilities, but for other Autodesk products as well. We have various other technical staff that upload videos onto our YouTube channel on a regular basis. So if you're up for some tips and tricks, go have a look at the channel. So once again, thanks for watching. Like and subscribe for more information. And if you want notifications, click that bell and you'll be notified of any live webinars and new videos that come up. Micrographics contact details, also bottom left, mgfx.co.za or info@mgfx.co.za. Thank you and goodbye.